Okay, this is section 2.5 and it begins on page 99. Now, most of the time, I don't do the exploration, but the exploration is instructive this time, so we're going to do it. What I'm going to do is show you how to do exploration 1. Maybe. No, I don't. I think I'm just going to jump straight to exploration 2. And they've got most of the proof written down there. I want to show you how to start from the given and proof part, how to set it up, and how to do it yourself, because that's what you're going to be up against in the ethics test most of the time. So pretend they don't have any of that proof there. I would cover it up if I were you. And we're going to do the same thing that we've seen before with angles. The more exposure you have to it, the better off you're going to be. So if you were going to do this proof on your paper, you would start out by drawing a picture, either to the right or to the left of your T-proof. I don't care how beautifully it's drawn. It just needs to have the correct markings. And we've got C, E, A, B. You'll notice that you're sitting there watching me draw on the board and you're going, okay, well, my mind's in idle because I'm not doing anything. You're right. Setting these things up, getting them all written out, getting given and proof where it goes, getting the picture labeled and marked and drawn takes a long time. It doesn't take any mental effort. You just have to copy it. So proofs are different than algebra that way. Write down what you're doing and then you get after it. That's not the case here. It takes a while to get things drawn and set up. So I've got the drawing there. They also called, and you'll see that in the deal. This is 1, 2, and 3. And they have 1 and 2 or 1 and 3 marked as equal. My marking is different than theirs, but they're equal. They got the same mark. And you'll notice when I write down the given, I leave the M's off, which I told you before. So we write a big fat old T somewhere near this diagram, and we write angle 1 equals angle 3. And we wish to prove that angle CBD is CBD, I said, didn't I? EBD, EBA, and CBD. Yeah. Okay. It doesn't matter what order these are in because it's a symmetric property, but so I got CBD and EBA. It's different than the way I have it written. You don't have to switch it up. It doesn't. What I'm saying is it doesn't matter. These two big angles we want to be equal. Now the main notion on this is going to follow along like we've already seen before with angles. The main thing here is that what we were given were little. What we want to prove are bigger. They're both bigger by angle 2. See it or not? You see it? Do you want me to put the two angles in that we're trying to prove in color so you can see it better or not? We're trying to prove that this red one right here, CBD, is equal to this green one. I'm only highlighting them so you can see them with that. By coloring like this does not say they are equal. I'm trying to prove the big red one is equal to the big green one. And both of those are bigger than what we were given by angle 2. Which means we're going to have to add angle 2 at some point. We've got to add it in order to be able to see that the big ones are equal. And I think we should do it right now. How can I get angle 2 mentioned? With angle addition. Good. Sorry. That's what we're going to do. We're going to add a couple angles together. Which ones? Angle 1 and angle 2. And what does angle 1 plus angle 2 equal? CBD. And if you have, by the way, and I'll let you do this, if you have colored pencils, you can say equals red if you want. That's not customarily done. And so I'm not going to do it because I don't usually use color to mark it. So we actually have to give it a name because they're up here. Or you can say red and green. Red equals green and have it red and green on here. That's fine. As long as I can clearly see what you're trying to prove. But I don't have these red and green, so I'm going to say CBD. That's what those add up to. And again, this is the heart and soul of angle addition. A little plus an adjacent little equals the big that contains them. Little plus little equals big. Angle addition. What else can we say? EBA. I'll call it with the EBA. Both of those are for angle addition. Little plus little equals big. Now here's the part people can't seem to remember how to figure out. when you're doing an addition one, that is, you're given little stuff and you want to prove bigger things, you have to have an actual addition step. And the addition step comes from the given, not this, not this. That comes from there. And what do I want to add? Well, take a look at what we've got. Here in this statement right here, which allowed us to at least mention angle 2, I have, in this statement right here, I have that CBD, which I'm trying to prove something about, and EBA, which is over here. I want to say that they are equal. And they would be equal if only this equaled this. It does, but I have to say it. Angle 1 plus angle 2 does equal angle 2 plus angle 3. And it comes from this equation turning into this using the addition of angle 2 on both sides. So I took the given statement, I added 2 to both sides of it, and it gave me this statement. See, here's the 1 and 3, and I've added angle 2 to both sides of that equation. That's addition. You take an existing equation and add the same thing to both sides. Since this has now been stated to equal this, here it is. Since this equals this, and that's what I'm after. And the reason, anybody? Substitution. 2 things equal to the same thing are equal to each other. These 2 thingies are equal to the same thing. How do I know? Because I told you right there. This equals this. There it is. So if they are equal, these are equal. Substitution. Done. Okay. I don't know if I even want to do example 1. I want you to just look at it with me and see if you can figure out how it might go if you were going to write it. You guys in the back, if you want to talk, go out in the hall. If you're not going to pay attention to what I'm doing, then please leave. Example 1. I want you to just look at the picture and try to imagine how this one's going to go, because it's very much like this one. I'm pretty sure. Notice in the given it says angle 1 equals angle 3. Do you see it in the picture? Aren't those little guys? And it says to prove that DBA equals EBC. DBA is a huge one, isn't it? Big giant angle, DBA. And EBC, find that one, EBC. That's a great big one. So we started out with little ones that they told us were equal, and we want to prove some great big ones, and they're both bigger by angle 2. It's going to go exactly like this one. See it? You got little, you want big, you're going to have to add somewhere along the way. This is the step that most people can't figure out. You got to have that so that you can get these 2 left sides equal, so you can say the right sides are equal. That's the key. If you've got little and you want big. If you've got big and you want little, you're going to subtract something. Okay. Let's see. Okay. I actually want to do the monitoring progress with you because you haven't seen one like this before, so it's not really fair to try to ask you to do it. But here's what's going on with the example, with the monitoring progress. It says, given T is the midpoint of SU. So I need to draw a segment. Got that. T is the midpoint of SU. Now, does it say in those words, does it say that ST equals TU? Then don't mark it yet. If it actually says 2 things are equal, you can mark it. My recommendation to you, to be safe, to make sure you understand what you got and what you don't have, is that you don't mark anything until you've actually said this, made this statement somewhere. This equals this. Then you can mark it. That is not what it says. It says T is the midpoint. So don't be marking anything yet. We are given that T is the midpoint of SU. And we have some things actually in algebra marked on it. 7x equals 3x plus 20. I'm sorry, 7x, and then 3x plus 20. So we're mixing together algebra and geometry here. And we are going to try to prove that x equals 5. That's our goal. Okay, so this is where your definitions come in. This is the first time you've actually had to use a definition in a proof, will you look up your definition of midpoint? Because that's a geometric word. Things, midpoints, bisectors, angle bisectors, complementary, supplementary, those are all geometric words with definitions. Find the one that says the definition of midpoint. That's what we're defining because that's the geometric word in the given. If you ever have geometric words in the given, you need to define them with an equation immediately. With an equation. Did you find your midpoint one?
Yeah.
If it tells you that, in this case, that T is the midpoint of SU, what does it mean?
ST equals TU.
It does. Here's what most people say. Thank you, Mark. Most people will say it means it's right in the middle, which is useless to us for proof. We need our definitions to give us equations because we manipulate equations to get to the bottom. We don't have a single equation in this thing yet. So we define midpoint with an equation, which in this case, with reference to this picture, means that we're now saying that ST is equal to TU. How come? Because that is the definition of a midpoint, that the two halves are equal. You define all words with an equal sign, with an equation. Okay? We want to prove something about X. I now know that ST equals TU, and I can now mark it. Because I've said it, now that it's been said. So this is kind of tricky when you haven't seen it used this way before, but I can now write this. 7x equals 3x plus 20. Anybody have an idea why I can say that based on this?
Substitution.
Yeah, see, he's jumping right to the point. A lot of you are saying because they're equal, and you're telling me what you're seeing. But ST and TU can be replaced with what they're equal to up here. That's substitution. We're substituting 7x for ST and 3x plus ST or TU because it says they're the same up there. So now I finally got myself an equation, but not till I said this was equal, so I could say this was equal. Now we manipulate by solving the equation. What's the first thing you want to do to solve that? Subtract 3x, and what will you have? 4x equals 20. So you write down the result, and the reason was subtraction, just plain old subtraction like you do with every equation. 5, and then, and what will you get? And the reason? Division. Are we where we want to be? Yep, done. So sometimes you got to use the geometry to get an equation in here by defining that word in this case. And then you make substitutions with the algebra and continue solving one step at a time. Did y'all follow? Okay, that was the monitoring progress. Now, I don't want to do example 3. Let's see. Let's do example 2. We're naming properties. In the property in this statement says if T equals V and V equals R and then T equals R. What's that called as a property? Substitution is great. What's another way of saying it? Transitive, which we won't use in proofs, but you could call it transitive or substitution. I prefer substitution. Okay, look at the B part, see if we can name this property. JL equals YZ, then YZ equals JL.
Yes.
That's symmetric. That's symmetric. And you won't use that in a proof either, but it's nice to be able to recognize it. Okay. Example 4. This one's going to be one you haven't seen before either. This one's pretty interesting. So try to tuck this away in your arsenal of weapons if it comes up again. It comes up very rarely, but when it does, it's nice to know what to do. Okay, so this one's a little weird this time. It's not one of those addition or subtraction things. I have only one segment with an M in the middle. So here's my diagram. Very much like this one on the right, except we're going to prove something different with it. And I've got A, M, and B. Please notice that even the author of the book does not mark AM equals MB, even though we were given that M is a midpoint. You do not mark it unless you have an equality statement. So, in my proof, this is what I'm given. M is the midpoint of AB. What I want to prove is that AB What I ultimately want to prove is that AM is equal to half of AB. Here's part of the problem with doing proofs, because your mind is so good at this. You're looking at that and going, well, if M's the midpoint, then the two halves, then AM or MB, either one has to be half of the other one. Trick is to slow your thinking down so you can prove it based on what you know. Notice what I told you before. If you've got a geometric word, the first thing you should do is define it so you have some sort of an equation to work with. So in this scenario here, how will I define midpoint with an equation with this picture? AM equals MB. That's the definition of midpoint, that the two halves are equal. It gives you an equality. Okay, now the rest of this, you're going to look at it and go, are you kidding me? AM is half of AB. That's what we're trying to prove. I've got AM in there. If I'm going to prove that AM, this is what you're thinking after getting, if I'm going to prove that AM is equal to half of AB, I'm going to need AB in here somewhere. And I have AM and MB, so I got the AM, but I don't have the AB mentioned. How do we mention things? What?
AM plus MB equals AB.
Good. That's really good. The reason we can say that is for what?
Segment addition.
Segment addition. Very good. And because I needed to have mentioned AB someplace, if I'm going to prove something about it, I get it brought in using either segment or angle addition. Segment in this case. Now, watch this, because this is tricky. And if you're already following along the proof in the book, you're not doing yourself any favors. Notice that the final statement does not have an MB in it. And I've mentioned it twice, but I don't want to have it in my final statement. I got to get rid of it somehow. So watch this slick little trick. AM plus AM equals AB.
Oh, that means substitution.
It would be. Because I'm replacing MB in this equation. I'm rewriting this equation. And instead of writing MB, I'm writing AM. How come I can? Because it says here they're the same. Slick. It's tricky. It's tricky. So I have rewritten this, lost the MB because there's nothing in M. There's no MB up here anywhere. And now I'm getting down to an equation that has only AMs and ABs, which is sometimes hard to do. But this is substitution because it's a rewrite of this, replacing MB with AM since they are the same. Now that's what we're going to do next. Yes, but I wanted you to make sure you can get from here to here. Eliminating the things we don't see, and at the same time, leaving the things that we do. So yes, you would write twice AM equals AB. Because something plus itself is two of those. X plus X is 2X, right? So AM plus AM is twice AM. And that is, as you said, combined like terms. We haven't seen that yet in a proof. That's what we did, is we combined like terms and got this. We're very, very close now. I have AM on the left and AB on the right, but I got the wrong things. What have I got to do? Divide. So that one's kind of weird. And the trick to this one is, to get it right, is you need to look at what you've got in your first equation by defining this. Look at what you want. You want the AM, you don't want the MB, but you got to have an AB. And the way you get things in is with segment addition. You mention things. And then you look at that and you go, but I still don't want that MB. Oh, but I could replace it, leaving me with AMs and ABs, which is what I want. So it's tricky.
Could we keep it in fraction? Could we keep it as AB over 2?
You could, if you had up here AB over 2. You need to make it look exactly like what you have written up here. And I don't care which, because they're both the same. But you can't say AM equals AB over 2 when this says half of AB. Even though they mean the same thing, they don't look alike. You need to finish with what that says. You know, that's it, folks. That's all the demonstration you get. The rest, you have to flounder on your own to come up and down. You've got it, and your stuff that you're going to be doing today may take pages, because I don't want more than 3 of these on one page. You've got to spread it out. What I do is I have a Up on the top of the page, I have the give and approve here, and I have a very nice big picture drawn here so that when I put stuff on it, it's not all crowded together. And it takes about a third of a page. So don't cram it together. I have 11 problems for you to do, that's all. They're not all proofs here, but there's enough of them, it'll take you some time. So, page 103, this is section 2.5, this is the assignment. Number 2, 3, 5 through 10, 13 through 15. Anytime it says prove or show, you're gonna have to have a diagram and a T-proof that mesh together and not drawn really tiny. So use some paper. Some people say that we waste too much paper. There are more trees in the United States today than there ever was when Columbus went. So quit you belly. We got lots of trees. You should be worried about the trees in South America, and not doing your homework all spread out is not going to save any of those. There you go.